So, hi guys, good evening, all of you. Are you audible, guys? Okay, right. And today topic is indexes. Okay, so the next topic is what now? Indexes. So basically, indexes, the main purpose of and the cause of indexes, why we want to create these objects on your table. Okay, means the reason is what now? To retrieving a specific row data or rows data from your table. Okay, so whenever you want to retrieve a specific row or rows data from a particular table, okay, so fastly retrieving purpose, quickly retrieving purpose, that means without taking much time, within short period we can retrieve the information from a table. So that kind of technique. So okay, so how to retrieve data in short period of time, okay, so the technique is telling by indexes. That's why suppose this indexes are very simple, guys, here. But before you want to understand this database index, I hope that everyone know this book index. Everyone knows this book index. Okay, now. So I think all of you know the book index page in your textbooks or whatever it is. Okay. So can you tell me, guys, here whatever index pages are there in the book? Okay. So what is the purpose of that? Okay. So book indexes purpose is what, guys? Book indexes purpose is what? Or what purpose we are using book index, guys, here? Generally, we all of you know nowadays, if you see every textbook is having index. Every textbook is having indexes as an or index page. So what is the purpose of a book index page? Yeah, simply we can say book indexes or index pages advantage is what now? So quickly or else fastly you can know or you can take your required topic from your textbook, because in textbook there are number of pages are there. The 300, 500, 1,000 pages are there in the textbook. But in these so many page numbers, there are so many topics, okay, now, or concepts are going to be having here. So out of these 500 or 1,000 or 300 page numbers, suppose you need a required topic from that textbook. So suppose your index page is not there. So what it was happened, the user has to search each and every page number. Okay, for example, like normal example, you can say, suppose Oracle textbook is there, for example. Oracle textbook. Okay, now this book is having total 500 page numbers. 500 page numbers are there. Okay, out of 500 page numbers, there are so many concepts we have. But assume this, guys, here, this textbook is not having index page. Okay, now there is no index page in this textbook. For example, who was the published this book? So those people are forgot it. Was published this textbook. Those people are forgot it to give a index page. Okay, so index page is not there in this textbook. Okay, what it was happening. So when index is not there in the textbook, Suppose you need to take any one topic here. For example, I need a joint topic. So if I want to need a joint topic, okay, what it was happening, guys, here. I don't know the topic in which page number, I don't know. In which page number, I don't know. So when we don't know, and also we are setting index page, but this book is not having index page also. Then what it will happen, guys, here, if there is a no index page and we don't know our required topic in which page number it is located in the book, that information also we don't know, right? So when we doesn't know, okay, the page number, okay, of my topic, and there's no index page, generally what we are going to do, guys, here, we are going to be performing one mechanism. The mechanism is called as what now? Setting. Okay, we are performing what mechanism? Setting. So searching mechanism we are going to be performing, right? And this is a searching mechanism. Okay, so how to searching means we are searching started from the page number. Okay, started from page number 1. So like this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, 8 and 9. So like this. Okay, now so each and every page number we are searching until your required topic is found. Your required topic is found. For example, your required topic was having in the 45 page number. Your required topic is having in the 45 page number. So what it was going to happen means the user has to search 45 page numbers in our textbook. So this is a lot of time consuming process, right? Now, okay, after that, after some time, next one is suppose we need a next mechanism is, for example, one of the mechanism is there, for example, views. If I want to take a views topic, again, what I want to do, guys, here, again, I don't know the view is having in which page number we don't know. Again, what we are going to do in here also performing what now? Searching operation. So searching operation, again, we have started from what now? Again, page number 1, 2, 3, 4, 5, 6, 7, 8, 9. So it was searching. Suppose your page number, assume this. So searching. The page number is having here, suppose 115. So 115 page number is your views. Okay, now. So like this, for every required topic purpose, we need to set each and every page number. Okay, we need to set. So this is a lot of time consuming process, and slowly we are retrieving your required topic. Okay, searching time is more, performance will be degraded. So performance also, very low performance will be happening here. Okay, so these are the problem. That's why the people, what they will do, they will create it what now with index page. They created what now with index page. Okay, right. So when we are creating index page now, for example, so what is the advantage of index page, guys, here? Okay, in index page, suppose you have an index page. In your Oracle textbook. So first page is called as the index page. So in this index page, there was clearly given us serial number, okay, na? And they given us topic name, okay, na? And they given us page number. So it's a clear information we have it in the index page. It's a clear information we have it in this index page. Okay, now serial number 1. What is the topic name? For example, introduction to Oracle. So this is page number. This page number is 1. Okay, now suppose second one is called as the SQL. page number 10. Suppose third one is called as a, okay, operators, and page number, for example, 24. Okay, now, so like this, we have, for example, joints. So joints is a page number 45. Like we have a like example of views. Okay, now, so the views is having in the page number 115. So like this, your in index page, it's a clear-cut information the people are telling us. The clear-cut information the people are telling us. So based on this information, what happens? Suppose I need a joints topic. When I need a joints topic, what it was happening, guys, here, I'm just going to suppose I'm the user. So I need a joints topic means I will go to my first priority index page. In index page, I'm searching joints is there. And joints is page number 45, it was given us. So based on this 45, what I want to do, directly I can jump. So directly what I'm going to do, so directly jump to 45 page number in textbook. Yes or no? Are you directly jumping now? Yes or no, guys? Okay. So because if you know your required topic in which page number, automatically you directly jump to that page number. Okay, directly jump. It means that the starting page numbers we are not searching, guys. So directly I will go. So in this case, what happened? We don't want to search. That means searching time is reduces. Quickly taking your required topic. Performance is also very high level performance will be give it. Okay, now time saving. So this kind of advantages are there. So this is general book index that everyone knows that what is the advantage of book index. Same like this. Come to database indexes also. We are going to be created, guys. Okay. The purpose of retrieving a specific row or rows data from a table quickly or fastly. Okay, now so simply you can say it is a database option which is used to retrieve a specific row or row data from a table. What is there? Simply we can say fastly. Okay, now so fastly retrieving purpose we are going to be using this index. Okay, now so as of now, whatever I was explained here, the book index how we are using same as database index also. Okay, now but here all database sites, okay, almost every database, so every database supporting two types of searching mechanisms. Okay, searching mechanisms. Okay, so what does that means? First one we called as a table scan mechanism. Table scan is called as the default mechanism. And second one is called as the index scan mechanism. So all databases or else every database is supporting. There are two types of mechanisms right here. There are two types of mechanisms are supported. So what are those means? Table and index. Okay, now so let me see. First, I will show you table scan mechanism. How this scan mechanism internally Oracle is going to be performed. Okay, let you see, guys. The first one is called as a table scan. Okay, now so what you want to say, guys, here? It is a default. Searching mechanism. Okay, in database. Searching mechanism database. Okay, now, and in this mechanism, what it was happened here, Oracle server, Oracle server, Oracle server is searching the entire, searching the entire, searching the entire, okay, table. Okay, so entire table. So entire table means, like you can say, top to bottom, top to bottom. Okay, now, so entire the table from first row to last row. Suppose in your table there are 1 lakh rows, are then 1 lakh rows are going to be searching. Okay, now, so that is what we have here indexes. Okay, now, right. And let you see how one small example I will tell you. Suppose generally when we are calling here, select the star from EMP, suppose where salary is equals to 3000, I was doing one of that means what I'm going to be doing here. I'm retrieving data from EMP table whose salary is 3000 rupees. Whose salary is 3000 rupees, right? Now this request, whenever user sending to server, then server what it will do, observe. So I just connect with my database. Okay, now, right. So this is actually our table. Okay, now, now from this table, salary is one of the column and total 14 rows are there. Total 14 rows are there. So what I'm going to doing, guys, here, what I'm going to do, I'm retrieving some information or some rows data from this table. Okay, I'm retrieving some rows data from this table. So whenever you want to retrieve the data from this table, okay, so how it was retrieving here, observe. How it was retrieving here, observe. Okay, let us see. Suppose we are direct, that means we didn't create any index on this table, so directly we are passing where salary is equal to 3000. So what it was happen, guys, here, whatever the user sending this request, the retrieving data request by using of where class condition. So this condition is going to be verified with each and every value in the table. So row 1, okay, 800 is equals to 3000, false. Okay, 800, 3000, false. 1600, false. Next 1250, false. Okay, 2975, false. Okay, now 1250, false. 2850, false. 2450, false. 3000, true. So 3000 is condition true. Okay, so whose salary 3000? This is true. Then this row data is displaying on the screen. Okay, as an output, this will be what display. Okay, on screen. Okay, next one. Next is continue now. Again, it will go to next record. 5000, false. 1500, false. 1100, false. 950, false. And 3000, true. Yes or no? This is also true. Condition is true. So this data also displaying on the screen. Next, 1300, false. So now tell me, guys, here, whatever the condition I was given this condition, based on this condition or with this condition, your Oracle server searching how many times on this table, how many times comparing, how many times searching. Come on, guys, how many times comparing your condition? How many times comparing your condition? Total, yes, total. How many times comparing, guys, here? total 14 times it was compared. 14 times comparing our condition. Our condition in the query, how many times comparing? 14 times. Suppose your table is having, for example, your table is having 1000 rows are there. Then 1000 rows are there means how many times comparing? 1000 times comparing. So 1000 times comparing for your retrieving your required data purpose. Okay now. So this is a lot of time consuming process, and your database burden increase, performance will be decreases, getting late responses, slowly retrieving your data. So a lot of problems are we are going to be facing, guys. Okay, a lot of problems are we are going to be facing. So this is what it was happen just normally without creating index. One query if you send and retrieve. So this data how it was retrieving. This data how it was retrieving means a total 14 times it was comparing and retrieving. That means each and every row. That means what now? Each and every row is individually one by one is comparing your condition. So wherever your conditional value is satisfied, that particular row data retrieving from the table. Okay, now this is called a searching from top to bottom, each and every value. Okay, so and finally the output was came to us like this. So now the situation will be happening now. So what I'm saying here, so this is this searching how many times, guys? 14 times as per this table, 14 times comparing our condition. Comparing, okay, comparing 14 times comparing. This is just keep it like this. Now let me see. Now what is my requirement? Is there any other technique was there? By using of that particular technique, I can retrieve my data quickly. That means less than 14 times. Less than 14 times. So that means, is there any possibility we have? Is there any alternative solution we have to retrieving the data less than 14 times? That kind of any technique or any kind of mechanism is there means yes. So that mechanism is called as what now? Index scan mechanism. That mechanism is called as what now? Index scan mechanism. So index scan mechanism, in this mechanism, what it was happened right here? Oracle server searching server is searching not entire table, searching based on an indexed column, based on an indexed column only it was searching. Indexed column only it was searching. So this entire table is not needed to search. It was indexed column wise data searching. So how it is, I will show you. Wait. So now this is what index. Okay, index and what happened? Oracle server searching based on an indexed column only, not entire the table. Okay now, and these these mechanisms, index scan mechanisms are how these mechanisms will be implemented on database tables means there are two methods are there to implement. One is we called as automatically index object is created by system, and through that index object retrieving what data. That is one mechanism. Second one is manually. Okay, second one is manually. So index scan, that means before you want to do index scan, first you need to create a index object is created. First we need to create an index object. But index object how to create on the table? Okay, na? Index object how to create on the table. So how to create on the table means there are two methods of it. One is automatically your system is created index objects on your table columns. That is one mechanism. Second one is manually. Manually means programmer, he will be created an index object on your column. Okay, so there are two methods. Okay, one is system created, one is user created. First of all, the first method, automatically. Okay, na first one. Let me see guys here automatically how to create your system. Okay, index objects means only the way here observe. So whenever user creating a table, okay, user creating a table along with along with along with unique or primary key constraint along with unique or primary key constraint then internally internally system system is creating system is creating an indexed an index object, otherwise an index object on those unique column or else on those primary key column automatically. Okay, now so automatically system how it was created your index object means so when users, that means when we are creating our tables, by using of unique constraint, otherwise by using of primary constraint, so automatically your system is created index object on that unique column on that primary key column. Okay, now so based on that columns it was internally the index scan is performed and retried. Okay, let you see how it is. Some examples. Come to our database type here. Like I want to see the tables here. Okay, guys, just give me the 1 or 2 minutes. Few tables I'm popping that. Okay, right. So now let you come out. I'm creating one table. Create table test number 11. Carefully observe, guys. Serial number integer 3 constant I was applied and name passing varchar of some sort. But when what I said, whenever user creating a table along with the unique constant key, then internally your system is creating index object. Let you see what happened. I'm going to creating one table test 11 with the unique constant I'm creating now. So table is created successfully, right? Now, so table is created successfully, but the question is coming out, sir, how that means so what now table is created means already your system is created index object. On which column index object is created? On unique column. That means unique constraint. On which column are you applied? Unique constraint. On which column are you applied? So on that column already index object is created by system. Okay, automatically. But sir, suppose you are questioning, sir, whatever the system is created index object, that object I want to see. Okay, I want to see the system created index object I want to see, sir. So how you can see it? The system defined index object. Okay, so there one data dictionary was there. That data dictionary is nothing but simply first observe user underscore ind underscore columns. So user underscore ind underscore columns, this is one data dictionary. Whenever you want to see your index name, your index object name, on which column is created by system, so that I can see by using of this data dictionary. Okay, now let you see in the data dictionary what it was there: index name, table, and column. So these three columns I'm calling. Let you come out. Select a column underscore name, comma, index underscore name. Okay, from what is your data dictionary user underscore ind underscore columns. Okay, now, so where table underscore name is equals to which table, guys? Here, test number 11. So now carefully observe, guys, here column name. Can you identify column name, index name? So what is my column name? Serial number. What is my index name? SYS underscore C005495. Okay, now. So SYS means what now? System defined. So system is created one index object on which column? Serial number column. So now this is the way you can see your index object. So guys, this is clear all of you. This is clear all of you how to see my index object name on which column I was created in a table. Understand all of you? Are you clear, guys? This, come on. Okay, na? Right. So when we created a table along with unique constraint, automatically your system, this is column name, headings, you can see headings, column name. What is column name? Serial number. Second one is what now? Index name. Index name is what now? Sys underscore C005495. Okay, now. So this is clearly column name and index name. On which table? Test 1, test 11 table, because my table name is what? Test 11. So test 11 table. Okay, so that means whenever user is created a table with the unique constraint, then automatically your system is created index object. In the same to same, the next one I said was test number 22. Suppose EID integer. Now I want to apply primary key now, and from salary I'm passing here. So number of compliance and to reviews. So this time also what I said, I'm creating my table with which constraint? Primary key constraint. So when you created, okay, when you created a table along with the primary key constraint, again, internally, your system is created index object. That's why SYS means what now? SYS means what now? System defined. Okay, now. So again, your table again on test 22 table, EID column is a primary key. So on that EID column, again, index object is created. If you want to see that information, again, this data dictionary, you just call your data dictionary, but table name is what now, guys? The test number 22 and see up here. Again, all same as the column name, index name. What is my column name? EID. My index name is what now? Sys underscore C005496. So finally, conclusion is what now? Whenever user is creating a table along with the unique and the primary key constants, then automatically your system is created an index object on those columns in a table. So point is clear now. This is This index name is created by not user. This index name is created by system. That's why SYS was given. This is the indication of a system defined, not user defined. It's an indication of system defined. Okay, now? Are you clear now? Right. Okay, this is what we called as, guys, here. Okay, automatically, internally, system, how it was creating an index object on your table column, right? This is automatically. But we said another method also there. We said another method also there. That is called as what now? Manually. So manually means who was created, guys? Who was created? User is created. What? Index object. So index objects are not the system. Index objects are created by user. Okay. So how to create it and how many types of indexes are created by user? Observe. Generally, user can create two types of indexes in database. Okay, first one we called as a B tree index, and B tree index is called as a default index in database. Okay, now second one is called as a bitmap index. Okay, now second one is called as a bitmap index. Okay, so that means there are two types of indexes the user can create on your table columns as per your requirement. One is B tree, one is bitmap. And your B tree index is called a default index. So that means whatever the system is created, this is which type of index is created. If anybody asks you, what you tell? Come on, what do you tell? These are whatever the system is created indexes now. Okay, these indexes are which type? A bitmap or B tree? Whatever your system is created now, this index is a B tree or bitmap? Come on. Yes, it is a B tree. There is no doubt about it. B tree, because B tree is what? Default. Because B tree is what? Default. So there is no doubt about it. Confidently you can give answer. Okay, now because it is a default index. That's why B tree, whatever the system is created, that is B tree index. Okay, but user has a two user can create a two B tree and bitmap. Okay, now right. But in this B tree, again types of some B tree index types are there. In the type of what now? First one is called as a simple index. Okay, these are all comes under B tree index types. Okay, types of B tree index. Second one is called as a composite index. Third one is called as a composite index. Third one is called as a unique index. Fourth one is called as a functional based index. Okay, now so carefully observe. So manually user can create two types of indexes. One is B tree and bitmap. And in B tree indexes, again, some types are there. One is a simple B tree index. One is a composite B tree index. One is a unique B tree index. One is a functional based B tree index. Understanding now? Right. And second type is bitmap. So let me see one by one. in this B tree index, suppose I will go for B tree index one by one. I will show you and how internally mechanisms happen. Okay, so that all we will check it out. Now, first one, simple index. What is simple index? What is the simple index? What is the simple index? Okay, na? Right. So very simple. There is no complicated. Very easy to understand. Okay, creating an index, creating an index object based on a single column, guys. Based on a single column is called as a simple index. Okay, so whenever user is creating an index object based on a single column, is called as simple index. Okay, right. So what is the syntax to create? What is the syntax to create? Create index name. Create index name on table name of a single column. Table name of what now? Single column. Only one column. Okay. So this is what it was going to be happening. By using the syntax, you can create. So let you see the same example, whatever the previously we discussed, that is a table example. So same kind of, same kind of select a start from EMP where salary is equal to 3,000. So when this request, whenever I'm passing to my Oracle, whenever I'm passing this request to Oracle, what it was going to do without index, it was searching every table row data, okay, na? And wherever matching data retrieving. Okay, na? That is happening here. So that's why 14 times are comparing here. But the same request I'm sending after creating index object. Okay, na? This is before index object. Now I'm going to after index object. After index object is created, then later I'm sending this request. So based on this request, how your data arranging internally by system, and later how your Oracle server retrieving your data. Okay, let you come out and check. But before that, first come to in my table. I want to check in my EMP table. Is there any other indexes are there or not? So check out here. So some indexes are there. I just dropping indexes right here. Maybe previous batches purpose I created. Okay, right. I'm present in my EMP table. Okay, so only one index there. Okay, only one is there. Okay, na? So EMP number on EMP number PK underscore EMP. This is one index is created. That means in my table, carefully up. This is our table now. This is our table. Now in this table, there are so many columns are there. Okay, 8 columns are there. But 8 columns, so we have a EMP number is having index. It means that your salary column is not having any index, right? Now on salary column, do you have any index here? Okay, no. I'm creating now. Create index name. Index name is simple index SI1. Okay, na? So on table name is EMP of salary. column. So now successfully we created simple index SI1 on EMP of a salary. Okay. So after index is created on salary column, okay, then if you created indexes on salary column means it already B tree index is created. But the B tree index, how your salary column data is arranged in the tree structure format. Okay, so that we will check out here. Observe. After index is created, later I'm going to pass in select star from EMP where salary is equal to 3000. Okay, now, so when we are passing, which condition are you giving here? Okay, based on this condition only, your B tree index is arranged your data. So based on your conditions, your B tree indexed data arranged. So who will arrange this one? System will be do this. This work is done by system. So system internally now arranging as per user request where salary is equals to 3000. As per this request, now internally your system is arranging the salary column data into B tree format. How it was arranging internally by system, observe. So what we did, we taken here index created and we are asking this one. Okay, na? Right. So index is created and we are asking this. Now what happened internally, your system is performed. So first salary is equals to 3000. So 3000 is my root value. 3000 is my root value. So 3000 less than values storing at left side, 3000 greater and equal to values storing under right side. Okay, this is called as the right side and this is called as the left side. Okay, na? Right. So 3000 less than values are storing by your system at the left side of your tree, and equal or more than 3000 it's storing under right side of the tree. Okay, now right. So this is root as per your condition. This is your root. Now root after that, let you see how it was searching. Come to here for arrangement, how it was doing with the system. In this salary column, which is highest salary, guys? $5,000 is the highest salary. So 5,000 will take it and checking. 5,000 when you check to 3,000, 5,000 is greater than 3,000 or 5,000 is a less than 3,000? Is a big value or small value? Yeah, it's a big value. Big value means greater. Greater means which side storing? Which side storing? Right side. So now your value storing at right side. That is 5,000. Again 5,000. 5,000 above or equals to right side storing. 5,000 below, okay, below left side storing. Again same, because it is a parent level. This is the root level. Now okay. Now next one. Next one, what is your highest salary after 5,000? Next highest salary, how much, guys? $3,000. So 3,000, how many times are there here? 3,000 salaries rows. How many? 2. Let you come out 3,000. 3,000 compared to root value. 3,000 is equals to 3,000, right? So greater or equals to value. Which side now? Your 3,000 come to which side? Right side. Because greater or equals to, yes or no? Greater or equals to right side, less than left side. Okay, right side. So right, this is a root and come to parent. Parent compare now. Now 3000 is a big value compared to 5000. 3000 big value or small value? Less than 5000. 3000 less than 5000 means left side or right side? Left side. This is called a child level. This is called a child level. This is called a child level. So root, parent, child. In child level, your data storing. Child level, which side? Left side. Child level, left side. So 3000. So 3000. But the 3000, tell me guys, but the 3000, how many times is there means 2 times. So that means 2 times means here I'm taking 2 stars. Star, comma, star. Here star is representing, careful observe. Here star is representing row ID. Here star is representing row ID. And we all of you know, each and every row is having row ID number now. Come on guys, each and every row having a row ID or not? Yes. So here 3000, this is one row. This is one row and this is another row. So that's why 2 asterisk symbols I'm taking. Here asterisk is represented row ID. Row ID. Okay, now just keep it. Just keep it. So this is okay, left side. It will be okay, fine. The next one is next highest salary. How much, guys? 3000 after next highest, how much? 2975. 2975 comparing with the root less than or greater than? Less than. Less than means left side or right side? Left side. So left side storing. Left side storing. Left side, what is 2975? Okay, now 2975. So 2975 again less than value left side, 2975 greater than or equals to value right side. Okay, now same parent is making here. Okay, after parent is making. Okay, after parent is making. Okay, fine. This is parent level. Next 2975 after next highest salary 2850, right? 2850 only one time, right? Come here. 2850 compare with 3000. Left side or right side? 2850 comparing with 3000. Left side or right side? Left side. Left side come to 2975 comparing with the 2975. Left side or right side? Left side. So here it will be storing 2850. One asterisk symbol. Why one asterisk means only one row is there. Okay, now that's over. Next value. After 2850, what is your next highest salary? 2450. 2450 compare with the root 3000. Left side or right side? Left side. Left side parent compare. Parent 2975. Left side or right side? Again left side. Now we are storing. What is that? 2450. 2450 is also having only one row, one star. Next. Come to next one. After 2450, what is your next highest? What is your next highest? 1600. Yes or no? 1600? Yes, 1600. Compare with 3000. Left side or right side? Left side. Compare with 2975. Left side or right side? left side. Okay. So left side 1600, left side only one row ID. Three levels. Okay, right. Next comma. Next comma. After 1600, what is your next highest salary? 1500. 1500 compare. 3000. Left side or right side? Left side. Compare 295. 2975. Left side or right side? Left side. So left side I'm taking here because my space is not there. That's why I'm taking next line. Okay. 1500. 1500 is also one row. Okay. Right. After 1500, what is your next highest salary? What is your next highest salary? 1300. 1300 come out here. Compared to 3000, left side? Yes. Compared to 2975, left side? Yes. Now left side I'm storing. 1300. Only one star. Next one. What is the next highest salary? 1250. 1250, how many times are there? 2 times are there. Okay. So comparing here 1250 because 1250 also left 2 as symbol 1 comma 1 because 2 times is there, comma. Next 1250 after highest is how much? Next highest 1100. So 1100 is also storing at the left side and it is only one time. Next, what is the next highest salary after 1100? 950. So 950 also cash usual, here only storing 950. 1 absent symbol. Next, after 950, what is the next highest? 800. So 800 also coming to you. So 800 also left. So now your system arranging like this. After arranging your B tree structure format data, then later this conditional value, whatever user sending to Oracle. Now Oracle, what it will do? Now Oracle server come to B tree index. Come to B tree index. Now comparing this condition, Oracle server. First comparison, root level comparison, because it's a very clearly I'm telling, it's a root level. Don't confuse. It's a root level. It's a parent level. It's a parent level. It's a child level. It's a child level. It's a child level. Okay, now that's why this is called a tree. B tree. Tree means levels are there. Okay, now right. Now this condition is comparing. First the root level comparing. First root level comparing. So salary is equals to 3000. So 3000 is equals to 3000. Root comparing. 3000 is equals to 3000 means which side it will go? Which side it will go searching? Left side or right side? Right side. Now one comparison here. First comparison root level. 3000 is equals to 3000. So right side will come to you. Right side in the parent level 5000 is there. So here also comparing. Second comparison. So 3000 is equals to 5000. Is it is equals to or less than 5000? Less than 5000. Less than 5000 means where it will go? Child level. Child level, what happened? 3000 is equals to 3000. This is third comparison. 3000 is equals to 3000 condition true. So one time true and second time true. So 2 times you're matching. Okay. Now, so 3000 is equals to 3000 conditions are matching here in the child level. And this 3000, how many times is there? 2 times is there in my table. So 2 row IDs are. So first row ID, whatever it was there, directly it will go to table. Directly it will go to table. Okay. And in table, first 3000 row ID retrieving data. Okay, retrieving. Next, second is there now. Again, second one is same now. So now it will go to second row ID. Second row ID 3000. Second row ID 3000 row ID basis. Directly it was going to be retrieved. So that means what happened, guys, here? Based on this B tree structure, whatever the row IDs are there, based on this row ID in your B tree structure, based on this row, directly going to table. Directly going to table, and that particular row ID basis your data retrieval. So later here, next, like this, how many rows are there? How many times it was there? That row IDs are 1 and 2. So 3000 successfully retrieved. But these 3000 retrieving purpose, how many comparisons are happened, guys? First comparison root level, second comparison parent level, third comparison child level. So that means how many comparisons you have done? Come on. How many comparisons you done? 3 times. 3 times comparing. Okay, na? 3 times comparing. But this is index scan, right? But your table scan, same request, same query request. When we sending to SQL to your Oracle server, then in table scan, same question, same request, how many times comparing? How many times comparing? 14 times. So same request without index object, if I'm sending to my Oracle, then Oracle server 14 times comparing. But same request after index object is created, same request after index object is created, then how many times, guys? 3 times. Now tell me, which performance is good? Table or index? Okay, now? So this is index advantages. So that's why the people saying that what is the main cause of purpose of index means retrieving a specific row or rows data from your table fastly, quickly, within short period of time, within less time, I can get my required row or rows data. So this is a need of indexes, why the real-time people are created index objects on big tables. Understanding? So in such a way, you can easily fetching or retrieving data from your table, whether your table is having 1 lakh rows or 2 lakhs rows or 5 lakhs rows or none of the matter. Okay, now we are retrieving our data as soon as possible, is quickly within the less time we can get it. So this is B tree index internally working nature. Okay, now? So, and in B tree, okay, internally how it was working in this example, you can check out. Okay, and this is simple index, single column creation. That means we created index object on single column. Okay, and remaining indexes are there: composite, unique, and functional, and bitmap. So these are we're discussing on tomorrow, guys. Okay, so tomorrow we will go to next level of indexes. Okay, right, guys. Thank you so much.